Here is the uncomfortable truth. In a lot of RAG systems, the big embedding model is not making you smarter. It is just making you slower and more expensive.
Exactly. The real question is not which model is most impressive on a benchmark. It is which model retrieves the right chunks for your data, your latency target, and your budget.
So, this is not a beauty contest. It is a retrieval decision with business consequences.
Right. Embeddings turn text into vectors, so you can search by meaning, not just keywords. In RAG, that retrieval step decides what context the generator sees, and bad retrieval poisons everything after it.
And this is where teams get trapped. They assume a larger embedding model means better recall, better answers, better product.
Sometimes yes, but not automatically. Larger models often capture finer semantic distinctions, handle messy language better, and generalize better across domains. But if your corpus is narrow, repetitive, and well-structured, the smaller model may already separate the useful from the useless.
Give me a concrete case, because this is where people overspend without realizing it.
Imagine an internal docs chatbot for one engineering org. The docs are mostly runbooks, service names, API references, and incident notes. Queries look like, how do I rotate this token? Or where is the Kafka retry policy? A smaller embedding model can be enough, because the language is consistent and the document types are stable.
So the smaller model wins because the search problem itself is simpler.
Exactly. You do not need a model with broad semantic nuance to distinguish between 10 recurring operational concepts. If retrieval quality is already high, paying more for subtlety you do not use is just margin leakage.
But there has to be a catch. When does the small model start losing?
When the data gets ambiguous, multilingual, noisy, or conceptually broad. Think support tickets mixed with product docs, sales notes, legal terms, and user slang. Larger embeddings are more likely to connect non-obvious phrasing and preserve meaning across different writing styles.
So, if users ask one thing and the docs describe it a totally different way, larger models have a better shot.
Yes, say a user asks, why are refunds stuck after address verification? But the relevant document talks about post-KYC settlement holds. A small model may miss that bridge. A larger model is more likely to pull those chunks together, because it represents the semantic relationship more cleanly.
Now, let us talk pain, latency, and cost. Where do the differences show up in practice?
First, indexing. Every document chunk has to be embedded. Larger models usually mean more time and more money to process the corpus, especially when you re-index often. Second, query time. Each user question must be embedded too, and that hits your tail latency on every request.
So the cost is not just upfront. It sits in the hot path.
Exactly. If your app handles lots of short queries, query embedding cost and delay become visible fast. Even small differences per request compound across traffic, and they change whether retrieval feels instant or sluggish.
Give me another practical scenario where that trade-off matters.
A customer support assistant for an e-commerce site is a good example. If most queries are simple, like shipping cutoff, return window, invoice download, and order status policy, a smaller model can keep responses snappy and cheap. If your retrieval quality on those intents is already strong, a larger model may add cost without changing the answer.
But if you are a global marketplace with mixed languages and fuzzy policy wording, that changes the math.
Completely. Then the failure cost is higher too. A missed policy chunk can produce a bad answer, and a bad answer can turn into a refund, a compliance problem, or a support escalation. That is where better embeddings can earn their keep.
So the real contest is not small versus large. It is retrieval gain versus operational drag.
That is the frame. Ask, does the larger model materially improve top K retrieval on the queries users actually ask? Not benchmark queries, not cherry-pick demos, your real traffic, your real corpus, your real failure cases.
And if the improvement is tiny, the smaller model is not the compromise. It is the smart default.
Yes, smaller is enough. When your domain vocabulary is tight, your documents are internally consistent, your users phrase things predictably, and evaluation shows little lift from going bigger. In that situation, simplicity is not settling, it is discipline.
There's a strategic angle here too. Teams that overspend on embeddings may have less budget for better chunking, metadata filters, re-ranking, or evals, which might matter more.
That is a huge point. A mediocre retrieval pipeline with a large embedding model can still lose to a well-designed pipeline using a smaller one. Good chunk boundaries, metadata constraints, query rewriting, and re-ranking often buy more quality than blindly scaling the embedding model.
So who wins? The team with the largest vectors, or the team that understands its retrieval problem?
The second one, every time. Large embeddings are powerful when the semantic gap is real. Small embeddings are enough when the domain is narrow and the task is clean. The winner is the team that can prove the difference instead of assuming it.
Which means choosing embeddings is not about prestige. It is about refusing to pay for intelligence your retrieval stack cannot actually use.
Exactly. In RAG, the best embedding model is not the biggest one. It is the one that earns its place on the query path.